Audio Jungle.
Welcome to Spydur Technologies. My name is Jason, and today I'd like to answer one of the most common support questions we get, and that is to describe the boot process of an IP telephone. And while all telephones do have different features and attributes, the actual boot process is fairly identical regardless of manufacturer. The first step in the boot cycle isn't actually in the telephone, but rather in the network switch it is connected to. That is to say, the vast majority of telephones will receive their electricity through power over Ethernet, which comes from a PoE-enabled network switch using the 802.11af standard. This offers centralized power distribution in that you can put a PoE network switch on a battery backup and all of your telephones will stay up and running during a power outage. A typical power draw for a normal telephone might be 5 to 7 watts, whereas a larger telephone, such as for a conference room, may pull in 15 watts. Two important notes regarding power. First, you can safely plug in any non-PoE devices into a PoE-enabled network switch just fine. If your computer, laptop, or printer doesn't need power from the network switch to run, the network switch will simply turn off the PoE on that port. Second, you should either use PoE with your IP telephone, which is preferred, or use the power adapter that came with your IP telephone. Please do not use both a power adapter and power over Ethernet at the same time. Yes, the telephone will work just fine, but you really shouldn't and are just asking for problems down the road. The second step in the boot cycle is again in the network switch and not in the telephone. If your company is using VLANs, where you have multiple networks set up, one for computers, one for cameras, one for telephones, this VLAN information will be handed down to your IP telephone. Your telephone will then take this VLAN information and send out a broadcast message on the appropriate virtual network, looking for DHCP information. If your site has a single flat network with no VLANs and all devices can communicate with one another, then your telephone will simply send out that same broadcast message, again looking for DHCP information. Now, lots of devices can act as your network's DHCP server, but you generally only want one. Please watch our previous video on duplicate IPs for more information as to why this is so. For most smaller networks, your router will be the DHCP server. For larger networks, it may again be the network switch or even a Windows server. The DHCP server will assign the telephone a private IP address for use within your building. It will tell the telephone where the router or gateway is so it can get out to the internet if need be. And the DHCP server will also put out various DHCP options. The vast majority of telephone manufacturers use DHCP option 66, but some also use option 150. Older IP telephones, such as Nortel as an example, may actually use custom manufacturer-specific options. The purpose of the DHCP option is to point the telephone to the address of its provisioning server. Your Spydur PBX is a provisioning server. Just to recap up to this point, the telephone is now powered up on the correct network. It has a private IP address. It knows the IP address of your router or gateway to get out to the internet, and now the telephone knows what address to use for provisioning. Your telephone will automatically reach out and connect to the Spydur's config network share via TFTP, FTP, or HTTP, depending on the manufacturer of your telephone. Now, your telephone already knows its own make and model, what type of telephone it is. The telephone already knows what version of firmware it is running. And it also knows its own unique MAC address, which you can find printed on the back of the telephone. And assuming you already have mass provisioning set up in your Spydur, which is the subject of another video, the telephone will ask the Spydur for any updated firmware and programming information. Again, based upon the model of telephone and its own unique MAC address. If the firmware or programming is different than what is already loaded, the telephone will then update itself and reboot a second time with the updated firmware and programming. If the firmware or programming is already up to date, the telephone will simply continue its boot cycle. Now, let me take a break and describe 98% of the telephone manufacturers out there. If, at the end of the day, you log into a telephone's web interface or thumb through the telephone's LCD and you update its programming, your telephone and all of its programmable buttons will work beautifully, just as you intend, until it reboots, that is. In the boot cycle, when it reaches out to the provisioning server, it will see its original programming and revert all of the manual changes that you made via web interface or LCD. Assuming you want to keep your manual changes, you'll need to either update the mass provisioning on the Spydur with your manual updates, or what most people do, you can simply disable the mass provisioning of your telephone. You can do this by simply using your computer to navigate to the Spydur's config network share and move your telephone's configuration file, which again is identified by its unique MAC address, found printed on the back of the telephone, and simply drag and drop that configuration file into the disabled folder. This way, when your telephone goes through its boot cycle, it will not revert your programming, and you can simply manage that telephone via web interface. I said 98% of all telephone manufacturers work in this way because Polycom, or now simply Poly, and also Spectralink, which Polycom sold off years ago, have a very nice feature in that they provide a nifty little thing called overrides. The way overrides works is if you make a manual change in the telephone's web interface or on its LCD, the telephone will actually reach out to the Spydur and update its own mass provisioning. This is a great feature to have, but I will warn you that many technicians have pulled out some hair trying to figure out why their mass provisioning isn't working, not realizing that there is a separate overrides directory that supersedes the mass provisioning. But like I said, overrides are really nice once you understand it. And now that I've described how telephones automatically provision through the Spydur, I need to also mention zero-touch provisioning, or ZTP. Some telephone manufacturers are now starting to offer mass provisioning over the internet, whereas a telephone will reach out to your telephone manufacturer's website and again look for firmware and programming updates. Please note that these manufacturers are not providing telephone service, only provisioning. Instead of provisioning on the Spydur, you're using the manufacturer's ZTP service website to program one of their telephones, which is then connecting to your Spydur PBX. This means you can ship one of their telephones to a remote worker and it will automatically load its programming on first boot to connect remotely to your Spydur PBX. For the security conscious, let me reiterate this another way. The telephone will reach out to the manufacturer's servers to look for programming information to connect with your telephone system. If you do not want telephones reaching out over the public internet to a server that you do not control for programming information to connect into your network, simply use the provisioning built into the Spydur, and no communication will ever leave your building unless you want it to. This is just another way to program telephones and is based solely upon your preference. Regardless of how you choose to provision your telephones, if there are any firmware updates or program changes, the telephone will simply reboot and start the entire boot process again with the new firmware or programming changes applied. The last step in the boot process is the telephone will finally reach out to your Spydur PBX fully updated and programmed and say, I would like to be extension 123, please. Assuming that your provisioning is correct, the Spydur will tell the telephone, okay, you're now extension 123. This is what we call registering an extension, where the telephone registers as extension 123. Now, whenever you have a call for extension 123, the Spydur says, I have an IP address listed for that extension and passes the call to your telephone, which will then ring. I know a telephone's boot cycle can be a painstaking process with many steps, but hopefully this takes some of the mystery out of what your telephone is doing behind the scenes. At the end of the day, this is why we're here. So please contact us and let us get you up and running with your next project. We would love to help. Thank you.
Please remember to like, share, subscribe, and click the bell icon for notifications of new videos. Thank you from all of us at Spydur Technologies.